Hello students, we can see the chapter 1 real number. In this chapter, this topic is very important, that is fundamental theorem of arithmetic. It's explained two important concepts. First one is every composite number can be expressed as the product of primes. Second one is that prime factors, that is the factorization, it can be in any order. That is the second concept. So if you see the example, you will get a clear idea. Our example is 210, express 210 as a product of primes. So just you take a 210, you do the L division. Already you have studied in your smaller classes. If you have any doubt in this L division, you see the separate video for this and you just try to know this, then you know that. So you have a 210. First I have divided by 2, then I have divided by 3, 5. It's having like this. Here at the starting time itself I have divided by 7, then it's 30. 30 means definitely it's divisible by 3, 3, 2 like this. So the 210 can be expressed as 2 into 3 into 5. If you see this in this way, if you are dividing, means you have 2, 3, 5, 2 into 3 into 5 into 7. Here you have, if you divide like this in this way, you have 3 into 2 into 5. Okay, then you have, it can be in any order. 210, it can be, you can have a 2 into 3 into 5 into 7. You can write like this, otherwise you can write like this also. 7 into 3 into 2 into 5. That is the concept. That is 210. Actually, it's a first concept is 210 is a composite number. It expressed as the product of primes. If you multiply this prime number, you will get a composite number. That is the first concept. Next one is, it can be in any order. You can have this form, you can this form, but both are same. That is the second concept. Now we can see your exercise problem. Your exercise problem, or first in your exercise 1.2, first sum, you have a fourth division. Fourth division sum is 5005. I have divided like this. 5, it's ending with 5, definitely it's divisible by 5. So I have 1, it's ending with 1 means it's divisible, it can be divisible by 3 or 7 or 9 or 11, like this it's coming. It's not divisible by 3. So next I have tried to divide by 7. So I have 7 means 7 ones are 7. You have a 3. That 3 you should keep in between this. You have to imagine like this. You have a 30. So 7 4s are 28. 28, it's you have a remainder 2 that you have to keep here. Just you have to keep 2 here. You have to imagine this. So you have a 21. So 7 3s are 21. Like that, if you divide, you have a 11 and 13. So 143, actually it's coming in 11 table. So 11 ones are 11. You have remaining 3. Just you have to imagine this 3 here. So it's a 11 3s are 33. So this 505 actually is expressed as the product of primes. Next we can see the finding HCF and LCM by prime factorization method. That we can see. For this concept, we can see the exercise sum 1.2, second sum, second division. That is you have to calculate the HCF and LCM for 510 and 92. So just 510, I have done that L division. I have the factors 2, 5, 51 like this. So if you divide 92, if you do the L division, you have the prime factor like this, 2, 2, 23. So 510 I can write like this, 2 into 5 into 51. 92 I can write, instead of writing 2 times 2, I have written 2 power 2 into 23. So for these two numbers, I have to find the HCF and LCM I have to find. So for this, it's very important one, that is formula, that is HCF formula. That is, HCF is product of smallest power of each common prime factor in the numbers. HCF means product of smallest power. Smallest power means smallest power of each common prime factor. So for these two number, common factor is 2. 2 actually is the common factor. For this common factor, I have to take smallest power. Smallest power means here it is 2 power 1, here it is 2 power 2. Which one is smallest power? The 2 power 1 is the smallest power. That I have to take for HCF. So smallest power I have to take for common numbers. Common prime factors I have to take the smallest number. Then LCM means is the product of greatest power. Instead of smallest power, in LCM I have to take greatest power. I have to take greatest. Greatest means here greatest power of each prime factor involved in the number. Each prime factor involved in the number. So I have to take all the factors I have to take. First I have to take the common number, common prime factor. For these two, it's a greatest power is 2 power 1, 2 power 2. Greatest power is 2 power 2. That I have to take. The remaining number also I have to take. For remaining number also I have to take the greatest power. So if you see this example, you will get a clear idea. HCF is here. HCF is for common prime factor, you have to take a smallest power. Here the common factor is only 2. 2 is the common factor for these two number. 2 is the common factor. So smallest power only I have to take. HCF means smallest power. So I have taken 2 power 1. So your answer is 2. You don't have any other common factors. But LCM, I have to take the greatest power. I have to take a greatest power. Here these two, greatest power is 2 power 2. So I have taken 2 power 2. Then remaining numbers. Here you don't have any other common numbers. Then but we have to take that greatest power of each prime factor involved. All the factors, all the numbers I have to take. In LCM, I have to take all the numbers. HCF, I have to take only the common prime factors. So remaining numbers also we have to take. That's why I have written 5, that 51 and 23. 23, everything I have written. So if you multiply this, that is the 23460. That is the LCM for this one. Like this we can see the example 8. Find the HCF and LCM of 612, 120 using prime factorization. Instead of 2 numbers, here we have 3 numbers. For these 3 numbers, we have to find the HCF and LCM by prime factorization method. So in the solution, so just divide, do that L division for 6, 72, 120. So you have the prime factors like this. So 6 I can write 2 into 3 into 1. So 72 I can write here you have a 3 times the 2 is coming. So I can write 2 power 3. 2 times the 3 is coming. So 3 power 2. So like this 120 is also written like this. 120 also it's written 2 power 3, 3, 5. Like this it's written. So HCF means, HCF it's just like that brown color, in a brown color sketch it has written HCF. So HCF always we have to take a common factor. Common factor means for these 3 numbers, common factor is 3, 2 actually it's a common factor, 3 actually it's a common factor. Common factor means 2 and 3 it's coming in all 3 numbers. So HCF we have to take a smallest power. Smallest power means 2 power 1, here it is 2 power 3, here it is 2 power 3. Which one is the smallest power? 2 power 1 actually it's the smallest power that I have written. So this common factor. Next common factor is 3. For this 3, the smallest power is 3 power 1. So the 3 power 1 is taken. So it is 6. The HCF is 6. Like this, LCM. If you want to find the LCM for these 3 numbers, you have to take a greatest power. So for this common factor, greatest power is 2 power 3. So I have written 2 power 3. For this common factor 3 is also it's a common factor. Greatest power is, here it is 3, here also 3, but here only it's a 3 power 2. For LCM we have to take a greatest power. So I have taken 3 power 2. Then we have to take the remaining numbers also. LCM means we have to take remaining numbers also. But HCF we have to take only for common numbers. Smallest power for product of smallest power of common factors only. Common numbers only we have to take. So for LCM we have to take the remaining numbers also. So that's why I have taken 5 also. So if you multiply these 3, you have a 360. That is your answer. Like this, you try to do this example, some example 6, then exercise 1.2, first sum, second sum, third division. All the sums you can, if you get a clear idea, you can solve all these sums. Thank you.